In this lesson, we're going to learn about scientific notations or exponential notations. We have two reasons to use scientific notations. Either the number is very large or very small. A number is written in a scientific notation according to this rule. In this rule, we have two parts. The first part is called the coefficient, and the second part is called the exponent. The coefficient must be a number that's equal to or greater than 1 and less than 10. So it must be a one-digit number, and that number must be between 1 and 9. So 0 and 10 are not accepted. And the exponent is a whole number that we use as a power of 10 to show that how many times the decimal has been moved. Now let's try to solve an example, and we'll change an ordinary number into a scientific notation. And while doing that, we'll cover the three main rules that we use to convert a number into scientific notation. Now let's say we have this number. And the first thing that we're going to do is to place the decimal after the first non-zero digit, and the number should be less than 10 also. That would be after the 8, right? 8 is a number that's between 1 and 9. So that was our first rule, to write the decimal after the first non-zero number. Now, how many numbers we passed to get to our first non-zero number? 1, 2, 3, 4, and 5. We skipped 5 numbers to get there, right? If there was no decimal in the number, then the decimal is at the end. So we're going to read from right to left. Our second rule is to find the exponent, and we just did that. It's 5. We moved 5 steps to the left to get to the first non-zero number. Now we're going to delete the zeros at the end of the original number, as they are unnecessary to write. But remember, if they were between the numbers, then you're not going to delete them. And then we'll write the multiplication sign and 10 to the power of the exponent, which is 5. So the end result is 8.13 multiplied by 10 to the power of 5. Now one thing remains, as it's the third rule, is to write the sign of the exponent, which is a positive or a negative. Usually, only the negative sign is written. And if the exponent is positive, then we'll just keep it like that. How are we going to determine if our exponent is positive or negative? We have two ways to do that, an easy one and a difficult one. And we're going for the difficult one first, as easy stuff are also easy to forget, right? If the original number is larger than the coefficient that we found, then the exponent has a positive value. Plus, if the original number is less than the coefficient, then it has a negative value. Now in our example, the original number is greater than the coefficient, right? So the exponent has a positive value. Let's give another example that has a negative exponent value. We'll go for this number. This is a very small number, and the decimal is determined. We're heading toward the direction to find the first non-zero number. And this would be from left to right. Now we're going to head 1, 2, 3, and 4 steps toward the right direction to get to number 3, which is a number that's between 1 and 9. Now the easy rule is, if you're heading to the right side, then the exponent value is negative. And if you're heading to the left side, then our exponent value is positive. In this example, it's negative, because first, the original number is less than the coefficient that we found. And the second thing is that we headed to the right direction. Performing the same steps as before, This number will be 3.18 multiplied by 10 to the power of negative 4.